right, ladies and gentlemen, hello and welcome back once again. This is Eric Cavanaugh, and I'll be your host for a custom research webcast today, folks. We like to do these things now and again. We like to roll up our sleeves and dig into certain topics and try to figure out what's going on out there in the world of enterprise technology. And I can tell you, quite frankly, there's never a dull moment. So first of all, big thanks to our friends at Exaptive for sponsoring this research and this webcast that we're doing today. The topic is cool stuff, the next big thing, highly focused business apps. We're going to be digging into the details of what the folks at Exaptive have done. It's very interesting, I have to say. They've taken a new approach, and we'll talk about that today. You can send questions, of course, through the Q&A component of the webcast console. Don't be shy. Your questions help us have a good conversation here on these shows. So there's a slide about the presenters. Yours truly at the top. Dr. Robin Bloor is online today, and Dave King, founder of Exaptive. So let's talk about this new paradigm and what I mean by that. If you take a step back and do some historical thinking, you don't really plow fields with yaks anymore. You don't have too many cases where cash is being delivered by horse and buggy across the western plains. Not too many people do math with an abacus these days, although I would definitely commend someone who does. The abacus is a fascinating tool. But the bottom line is that there are new ways of getting things done, and you want to do things efficiently and quickly. So what do? You use the tools of the day. And it's interesting what's happening in the application development environment, as many of you out there probably know, is that we really are experiencing a fundamental transformation for how things get done. The whole movement of DevOps, I think, has been front and center in that transformation. And what we're going to talk about today actually takes things to another level, which I find quite compelling. And it's really very interesting stuff. So when I was talking to the guys from Exaptive, I guess a week or two ago, we were trying to figure out the angle to take on this webcast, and they made a number of really interesting comments. From the development side, we talked about the full stack developer, and the folks at Exaptive made a really good point that the environment has become so complex these days that it's really going to be very difficult to find that one person who can do everything from soup to nuts, who can set up your database instance, who can design your application, who can find and access the right data sources, who understands the business needs at hand, and most importantly, who really understands algorithms and how algorithms can customize applications and can customize things for specific users. And that's really what we're talking about when we talk about this concept of highly focused business apps. So it's just interesting to see how this happens, right? I mean, we've gone through all these different waves of innovation, and of course we've gone from the waterfall to more of the agile development paradigm. That's pretty much the case across the board these days. And there are lots of pluses, and there are some minuses too. You know, one of the jokes always about development is that the faster you develop, usually the less you document and the less you can go back and fix if you got something wrong. There are lots of tools around helping people deal with all that. But what the folks at Exaptive have done, I think, is very, very interesting. They've kind of figured out that there is some value, a lot of value, frankly, in having what they're calling a combinatorial marketplace where you can share and mix and match. Take code modules, take code, hard code, and use it in different ways and different styles and build some new applications. So that's what we're going to talk about today. And Robin is really just going to set the stage for all that. I'm going to hand the keys of the WebEx over to Dr. Bloor, and after that we'll hear from Dave King, who will do a demo of their environment. So with that, take it away, Dr. Bloor.
Okay. I thought that was a very good introduction, actually, Eric. And all I'm actually really going to do is expand on that to a certain degree. The topic of conversation here is rapid analytics, and there's no question about the fact that pretty much any company that's involved in building analytical applications would like to do it faster, and the advantages of doing it faster are fairly obvious. You know, the business process to getting to some kind of result is faster, and because of that, the benefit of any insights that you manage to generate occur a lot more quickly. So the the odd thing, I mean, it's odd when I kind of step back, think about 5 years ago when Hadoop was really quite young, and there was a fair amount of noise suddenly started to emerge about big data and what big data actually meant was analytics. In actual fact, I used to think it's not really big data, it's big analytics. But there's no question that analytics has become the business focus of the software market. We see a fairly large amount of new companies and a vast amount of new technologies that are associated with it. And it's acquiring sophistication at what I believe to be unprecedented speed. You know, if you think back to other eras of IT when we were developing online transaction processing, it took way longer to get to the level of sophistication that we are now approaching with analytics. It's come about through a whole series of disruptive activity. Some of it at the hardware layer, some of it in software, but right across the board. So if I kind of walk through this, first of all, sometime around 2004, we went to multi-core chips, commodity servers, and we started to move towards that should be MPP, massively parallel computing architectures. And the thing about parallelism is that if you scale out, then you just multiply how fast you can do something. So, you know, you don't get perfect linear scaling, but certainly 100 servers go almost 100 times as fast as one server. And that was a level of acceleration in terms of applications or applications that could leverage parallelism that we'd never seen before. We then got the Apache collection, which seems to grow all the time. I think there's at least 30 significant Apache projects. It all began with Hadoop. But the Hadoop distributions, when you look at them now, have a vast number of components to do various things with Hadoop. That created a need for people to actually have the expertise to bolt all of that stuff together. It's become more and more, it's become easier and easier to do that, but it's still not trivially easy. And then we got the what I would call streaming becoming mainstream situation. Previously, we'd had CEP in the financial sector and various niche applications of streaming. All of a sudden, the micro-batch technology from Spark and streaming technology, Spark and Flink, suddenly enter the picture. So previously, while we might have been able to do analytics on much larger collections of data, we're now able to do streaming analytics as well. And that changes the equation. We could never do that before. We've got streaming infrastructure, Kafka, MapR streams, two good examples. So now we don't just have the ability to build streaming applications, but we have the ability to build streaming architectures based on that technology. We had the emergence of the idea of a data lake and all the associated tools, and it became obvious, fairly soon after the popular growth of analytics, that there's a whole series of processes that you need to go through in order to be able to do analytics properly. And it begins with good data acquisition, goes through data cleansing, now involves data governance, and also the analytics applications themselves. We expanded out, and this is continuing to expand to external data sources, some of them unstructured, some of it's graph data. That meant that we had to have new databases, Cassandra, MongoDB, actually, and various graph databases became popular. We got the intervention of the cloud. Amazon has made a huge difference to analytics in the sense that I believe it's the case, but I read a statistic that maybe 30% of analytics, new analytics applications are actually being done by Amazon. So, the cloud has just removed a lot of the hassle associated with building appropriate hardware configurations. In fact, it's made that, down to minutes you can configure a meaningful hardware configuration. We've had the growth of analytical languages and libraries, R, Python, but also, libraries for machine learning. And we've had machine learning software and a whole series of private and open source machine learning components have suddenly emerged. And if you put all of that together and you think, well, that's just happened in, 5, 6, 7 years, it's a dramatic change. And it's all converged. I mean, there are other things that you can do with this technology, but mostly it's about analytics. The development challenge then is to orchestrate all of this stuff, whether you're talking about the hardware, the open source software, or specific analytics software. They're powerful technologies, but orchestrating it is a hell of a challenge. And it requires a development and deployment platform. Ultimately, that's what people want, is they want a development and deployment platform, and they probably don't care what's underneath it as long as they're getting the right performance and it's doing the things they expect to do. So they want the functionality and they prefer that the complexity disappeared. So the war against complexity. Complexity increases, has increased throughout the whole of the history of IT, but data growth and variability, that just continues. The hardware layer, that continues to evolve. We're now seeing, things like GPUs being added to CPUs or FPGAs being added to CPUs. We're seeing different kinds of memory, Intel's 3D Crosspoint. We're seeing a kind of revolution in the way that SSDs are used. All of these things are happening, and they make the building of software in those environments quite complex because, you can build software for the way that you understand the machine is now. But, if all of a sudden the basic architecture of the hardware changes, then the software will probably have to change to accommodate it. Messaging has become a big deal. And messaging isn't just to each other. I include in that the movement of data around, and I also include the idea of taking processes and breaking them up and distributing them as you actually need to do for Internet of Things applications. We've got application diversity. That's we've certainly got streaming applications that we never thought that we would see before. What we actually saw before with streaming was it tended to be windows on the stream, and so it tended to be analytics based upon windows of events. But in actual fact, we've also got now just straight event processing, and that leads to different kind of analytics, which isn't necessarily window-based. And that kind of application diversity, it continues to grow. I mean, I hear of new applications fairly regularly. We've got the security and governance problem. This has got a lot to do with the explosion of the technology, because a lot of the technology really wasn't built to have good security. And governance was never part of the equation. So those are being back-engineered into the environment, and they go all the way from the application to the bottom of the stack. And we've got to move to real time. So, the application, the whole stack is actually continuing to get more and more complex.
Hey, Robin, your mic is a little tiny bit hot. Maybe you could just push it slightly further away.
Okay. Is that better?
A little bit more, maybe? Go ahead.
How about that?
That sounds good. Go for it.
Okay. So the technologies of reuse. One of the major ways of making development easier and making the whole of the development stack work an awful lot faster for you is to employ reuse. And this has been done again and again throughout the history of IT. We see Well, we saw in the first instance, in the very early mainframe days, programming libraries, and that developed into modular programming. With the advent of databases, we've got databases and stored procedures, which are effectively reusable code. Then we got object orientation with the idea of creating reusable components of any size. And Corbo, which was the messaging capability that went with that. Then we moved to what I would call large-scale reuse with web services and a service-oriented architecture. And nowadays, and it's been, I suspect, emphasized in most people's minds by the way that mobile applications work. We've now got pluggable apps, which you can think of as functions. What we would have called an application in the past and what we call an application on a mobile phone are distinctly different things. Mobile phone apps are very much one-dimensional apps. But all of that is reuse technology. So rapid analytic application development, these are the things that, or these are the points that I would focus on in looking at any rapid application environment, and therefore I would apply it to analytics too. You know, is it additive technology? Can you add to what you already got in terms of your corporate environment? Is it an iterative development? Because that's fast development. Is there minimal physical coding? It's normally an awful lot faster to assemble, particularly workflow type of things. And this is very prevalent in analytics. Simply by using graphical capabilities and connecting one thing to another. Does it cater for data access and integration? Not just access, but also being able to integrate data access into the general data flow. And does it have data flow capability across multiple apps? Does it allow collaboration and reuse? Does it cater in any way for data governance? And is it a full lifecycle capability? And I'm hoping that those, because they are questions, I'm hoping that those questions are ones that Dave King can answer. So then now, ultimately the business only wants applications. So the enabling technology needs to be as invisible as possible. And fast development is, in my opinion, necessary. So I hand the ball back to Eric or straight to Dave King.
Yes, indeed.
Yeah, that's great. Okay, great. So can you guys see my screen?
Not yet.
Oh, not yet. I have to press this button. That's right. Let's do that. All right. Tell me if you see a network.
Now I can see it.
All right. So I think that Robin, raised some really excellent points, and there's some interesting vocabulary words that keep coming up, and I actually think sort of the best way to frame the discussion is to dig a little deeper into those vocabulary words. So, I guess what I mean by that is that we use the term analytics a lot. We use the term application. Sometimes we use those a bit interchangeably, or we sort of talk about an analytics application. I think it's important to unpack that a bit. And there's some other words that Robin mentioned that I think are worth diving into, like, what do we really mean by rapid and iterative and collaborative? But let me start with this sort of fundamental concept, which is the difference between analytics and application. And let me just check the sound levels. Eric, is this coming through okay? You can hear me all right?
Yep, you sound good.
Great. So what I've got here is a picture of a network, and the reason it's a pretty interconnected network. The reason I'm showing this picture is that as we get more and more data, and as we try and analyze those data in different ways, one of the forms of analytics that's becoming increasingly prevalent is graph analytics, network analysis. This is not just, sort of understanding networks isn't just about looking at data that represents a network. We also have things that Robin mentioned, like graph databases and storing your data in a network format. So networks are really becoming more and more important as data get larger and larger, and as we try and integrate different data sources or different data sets that starts to naturally form networks. So there's been a lot of interest in analytics as a means to analyze networks. And when we try and analyze networks, one of the first things we do usually is we try and visualize those networks. And that often, and that's what I'm showing here. So this network is a network that should be familiar to everybody. This is a network of flights across the United States and in and out of the United States. And you can clearly see the hubs of some of the major cities, and you can see where flights depart overseas. The reason I'm showing this is, in a certain way, this is where we are today with data analytics in a lot of ways. We get complex data, maybe it's network data, we try and visualize it, and we try and see if we can derive some insight from it. The problem is that's not always enough. When you try and visualize networks, you frequently end up with a pretty picture. Sometimes you end up with a hairball that might be a pretty picture. But you very rarely end up with a useful tool. And that's the distinction that I think Robin's getting at when he says businesses need applications. What I mean is almost everybody who's listening on this call, I'm sure everybody's listening on the call, has participated in the network that is shown on the screen right now, probably taken a flight somewhere. But when you booked the ticket to get your flight, you did not sit down at a network visualization like this and start clicking on nodes and edges and pulling them apart in order to figure out, how to get from Boston to San Francisco. What you did instead is you went to orbits and you just put in when you wanted to leave, when you wanted to come back, and then you checked, you sort of did some hypothesis testing. Would it be cheaper if I left a day earlier? Would it be cheaper if I left a day later? And then you ultimately booked a ticket. And I think this is a really important point when we talk about analytics, because I think in the world of analytics, we have been really focused on things like this, very data-y pictures. And we've been less focused on applications like this, which actually allow people to get work done with those data behind it. You can absolutely bet that Orbitz has that network of flights in its database behind the scenes. That's the only way it can work. But that doesn't mean that it makes you interact with the data like that. It gives you a workflow to navigate those data in a way that you can actually accomplish something. And so, let me pause there for a second. Robin, I think that was one of the points you were making when you said, at the end of the day, businesses need applications. Does this, anything you want to add on this point? I'm just trying for the listeners to really sort of set the stage of why this is an important distinction.
Well, I mean, I kind of agree with you, and I think it's a very good example. It's one of the things that actually happened with applications was that from the user's perspective, once the internet really started to fire, all that you got was a series of screens, and you had no idea of the complexity behind them. And this is just a very good example with Orbitz. It's a phenomenally complex application is going on, but you just put in one way or another a few details. You only have one requirement of the many things that you could possibly do with it. And it's over in a minute or two, and you've got what you wanted. And that's, for most people that are using IT within an organization, that's all that they want. If they could go to the IT department and just say, well, look, what we do with the customer here, we just require to see this piece of information, that piece of information, and the screen allows us to enter these details, and that's what we want. And, of course, it's often way more complicated to deliver than that sounds.
Well, that's a perfect segue. So, yeah, I think this idea that what a lot of people want is they want an application. This was sort of the ethos behind Exaptive. I mean, before I founded Exaptive, I worked in large volume manufacturing, and I ran a software team that delivered software applications internally to the rest of the company to facilitate the smooth operation of the company. And this would happen all the time, what you just described. People would come to us, whether it was managers or whether it was process performers that would come and say, you know, we need a program that helps analyze these data, or we need something that would help us automate these tasks. And what I found in that position, I was there for 12 years, what I found is all the points you mentioned, that we were never as fast being able to deliver as we wanted to be. We never had as much reuse among our projects as we wanted to have. And we spent a lot of time writing glue code to try and orchestrate the different pieces of the puzzle that we needed for a solution. And so, you know, what I saw as data analytics rose is that these problems of, you know, iteration and orchestration were just getting greater as all of the things in your earlier slides became more and more prominent. We have so many different technologies now that if someone wants to build an application, they very rarely now can do it just in one environment or just in one language or just in one technology. Now, in order to build a really useful application, they have to be able to connect together different pieces of technology to make an application. So the idea behind Exaptive, when we founded Exaptive a few years ago, was to focus on application development, specifically analytics applications, but we wanted it to make it easy, not just for people to analyze data, but for them to build apps. And so we decided that we would create this environment for building apps. An Exaptive application we called it Zap. So you can see what where I am right now is I'm in this home page of the Exaptive Studio, where I have a bunch of different applications that I built using the Studio. And so let's talk about what that looks like. So in the Studio, I can create my applications, my Zaps, but Zaps are just data flows. They are connections of components. And this is not, this is not a new idea. All good software development is based on the idea of componentization and abstraction. What we're trying to do with Exaptive is we're trying to take that to the next level, where we create a language-agnostic environment where components made from different technologies, contributed by different people, can be easily connected together by other parties into these Zaps. So you'll notice that I can create a Zap. I can also create a component, and we'll talk about both of those over the next few minutes. So let's start with the Zap. So when I go into the Zap builder, one of the things you'll notice is that it's web-based and it's a visual programming paradigm. This goes to what you were saying, Robin, about trying to minimize the amount of sort of manual coding that you need to do to support some data flow, workflow coding. Now, I'm a programmer myself, so for those of you that are listening, they're also programmers, I am naturally skeptical of any environment that doesn't let me get into the code. So it was very important when we designed this that we tried to strike a balance between the tools that would allow someone to be faster in their development, being insulated from code, but also giving programmers the ability to do all of the customization that they want to do by being able to get into the code. So I'll show you that. So you'll notice that what I've got here is I've got a canvas over here that is the data flow, and then I have a component browser where I have a set of components that are in my Studio, and those components I can add to the data flow. You've mentioned about the Zap store. This is a very important part of the architecture. Is that I've worked with too many systems that are closed systems. I sort of call this the Excel chart phenomena. Like, it's very easy to insert a chart in Excel as long as it's one of the charts that pops up in that set of options. If you want a totally different visualization in Excel, it's very hard. And other visualization systems, other analytic systems, in my experience, suffer from this, that they're optimized for the set of components that are inside that system, but they tend to become cumbersome to add new ones. And so that's why we made it very easy for any developer to be able to create a new component, and to do that in the language of their choice. Right now we support Python and R on the back end, JavaScript on the front end, but our architecture is very agnostic and it's easy to add other languages as well. So if I wanted to write, a machine learning component in Python, I'll call it my machine learning component, and I'll hit create. And what will happen is I will get this this set of GUIs that basically allow me to create an abstraction around my implementation. So I can say, this is a test machine learning component. I can define some inputs and outputs. So maybe I want to create a port that takes in some information about patient IDs or something like this. And there's lots of values. I can make other ports here, patient IDs. Maybe I'll take something about, location data. So I'm setting up my inputs, and then I set up my outputs. I can return data. I can return other things. And then I can write my implementation script right in here. And this is, for people that like to program, this is sort of my favorite part. You get right in, you write your Python code, and you save it. And the important piece about this is you remember that we were over here a second ago looking at the different components that were here. Well, if I search for machine learning, then this component that I just made is available here for me to pull into my studio. And you can see that now I've got my location and patient ID inputs. I've got my data output. I can easily get to the code, and I can modify it. I can make changes to these inputs. I can add a new port like this, save. And when I come back into the data flow, now I've got my new port there. So this is, I think, a very key part of the sort of exaptive architecture is we think about it a little bit like Wikipedia for data analytics, which is there's a set of components that are very easy for people to choose from, just like Wikipedia has a whole set of articles. But if there's anything that's missing, it's very easy for any programmer in the language of their choice to add something new. And we've created this explore page where you can see we've got this growing set of components that people can contribute to and then other people can use and can be monetized, because we also want people to be able to make a living by contributing analytics components. So let's go a little bit further with this. Let me show you something else that's important about the way we set up the environment. So you talked about rapid prototyping, and part of, I think, rapid prototyping is when you allow things to be done faster. It's not just about getting things done sooner. It's about lowering the barrier to experimentation and allowing new things to get done, because it's not so costly to try things out. So to help that sort of iterative environment, we made sure that Exaptive was a live programming environment. So I'll show you what I mean by that. I'm opening up a window over here on the right. And right now it's blank, and that's because my Zap doesn't have any visual components in it. I have this Python component, but that's not a visual component. I'll get rid of that for right now. So let me bring in a visual component like a button. And what you'll notice is when I bring the button in to the data flow, can you see, let's make sure the screen's refreshing. Can you see that I now have a button that has shown up over here in the live view on the right?
Yep.
Okay. So this is linked. What Exaptive is doing is it's basically compiling an HTML5 application on the fly as you build the data flow. So if I come in here and I change some of the options on this button, like I give it some text, hello world, and I send that new configuration into the button, then now my button says hello world. Let's add a text box. And you'll see that I've got my button and my text box right next to each other. Well, maybe I want to do some styling on that. So in this section, we have access to the HTML and the CSS. So for people that know, you don't have to know HTML or CSS to use Exaptive. We have templates that sort of do styling for you. But for people that know how to code HTML or CSS, I can create a new div here. I can take my, my text box, I can put it in my div, I can apply a style. So let's give this a margin top of 10 pixels. And I can set that up, and you'll notice that when I return to my data flow, can you see how now this thing has taken my new CSS changes, it's created a new div, and it's given it some margin. And I can get to the code here. So this text box code, if I look at the script, this is just a few lines of HTML, basically JavaScript. Now let's get to the analytics part. So let's start working with a data set. I'm gonna bring in an external data set. This is something that a lot of sort of developers and organizations are faced with, is that increasingly when they do data analytics, they have to be able to go out and work with data that lives somewhere else. They have to use an API. It's not just about connecting to their database. So what I've got here is I've got a PubMed search component. If we take a look at this component and we look at the script, you can see that this is Python, and what this is basically doing is going out to the NIH URL. Let's take a look at the info page. So every one of these components has an info page about it, so that someone who's using this component for the first time can understand how this works, what it does, and can basically see its inputs and its outputs and any dependencies that it might have. So this is something that is really helpful, again, in terms of what Robin was talking about, trying to find the right level of abstraction around code implementations. The other thing is now we can test this component independently from the broader application. So let's provide a query in here. This is a medical search database at National Institute of Health, NIH. So I'll use a medical query here, like cancer. And notice that what happens is the query lights up, and then when we have output from the server, the output lights up, and I can see that I'm getting back data. So if I want to render that, data, I'll turn off my Dropbox syncing here. So if I want to render some of the data, let's start with just a simple way of doing so, and then I'll show you guys something more advanced. So I'm going to grab a table, and I'm going to wire these components together. So when a value gets submitted to the text box, then it's going to set the query in PubMed search. When we get data out, it's going to put it into the table. And let's go ahead and just put in something like brain, and I'll hit return, and you can see the lights, the sort of lights on the ports lighting up here. And when the output lights light up, then I've got data in my table. Now, this is a very simple zap, but the fact that things can be so easily experimented with lets you build really powerful things quickly. So once I see I'm getting data in the table, if I want to remove this and pull in a word cloud, then I can bring in other components and I can start to wire those things together. So let me show you something that some guys on my team recently built. So this is something that was done as part of a hackathon, and I'm gonna close the live view and just go back to sort of one browser window. This was a hackathon. It had a couple different divisions. This the one that my team entered was sponsored by Hewlett Packard Enterprise, and they have a bunch of APIs, like an autocomplete API. You start typing something in, and it gives you a set of suggestions. And then they had some other APIs for doing natural language processing, entity extraction, concept extraction. And the hackathon was Hewlett Packard saying, hey, we have all these cool APIs. You have 24 hours. Let's see what you can build with them. And so using this data flow, this modular data flow programming environment, what the team decided to do was something similar to that PubMed example. They pulled in that PubMed component that I showed you just a few minutes ago, and they pulled data back from it. But if you see the progress bar over here, what's happening is the data from PubMed is being sent out to the Hewlett-Packard API for entity extraction. And that API is doing analytics on it to figure out what are the drugs that are being mentioned and what are the symptoms that are being mentioned. And so now you'll see we have this word cloud where drugs and chemical compounds are in blue, symptoms and phenotype information are in orange. And this is based on this list. So this is PubMed data that's come back. This is the sort of entity breakdown. And we have this interactive network diagram using D3. So again, the idea is, with Exaptive, we're not trying to create the sort of we're not saying, hey, we have a standard for visualization, you should use it instead of things like D3. We're trying to make it easier for people to leverage all the things that are already out there, like D3 or WebGL or natural language processing. And so here we have this ability to interact with this network. I can pick a start node, so I can say, if I want to start at this node and figure out how to get to the flu, then I can, maybe I have to pick a different. Okay, creatine. Then what will happen when I pick a start node and an end node is it'll build a Sankey diagram that shows me the path between the nodes from creatine to whatever the other start node was. So all of this functionality was built in 24 hours, and it looks like this. This was the data flow. And what was interesting is the guys won that division of the hackathon, which was really nice for them. And when they were walking the judge through what they did, the judge said, wow, you did this in 24 hours. Like, let's see the code. And what they did is they walked them through the data flow, and they were able to explain, well, you've got this autocomplete box. Then this is talking to this Hewlett-Packard Enterprise Haven autocomplete. They could pull this up and they could talk about what's in here, and you can see this is just a simple URL call. And then so this was like a custom component that was made for the hackathon. But all of these other things, right, like the PubMed search, was that reuse that Robin was talking about. They were able to reuse these components. And then, we're gonna iterate over the PubMed search results. That's gonna go to a couple different places. It's gonna get scaled. It's gonna end up in a couple of visualizations, a word cloud, a network diagram, a Sankey diagram. And when you click on a node in the network diagram, you get some interaction. So the power in having this data flow abstraction is that typically when people talk about code or talk about applications, they sort of only have two levels with which to talk. They can either talk about it from this perspective. They can look at the application and discuss it there. Or they can go into doing like a code review and end up talking about it at this perspective. One of these perspectives is too high level. The other one is too low level. That's why good engineers make system level diagrams, but not everyone does that like they should or as consistently. So what we've done with Exaptive is basically the act of building your application is the act of making a system level diagram, and it makes it much easier for people to contribute new ideas, because now someone can say, oh, what if we get rid of this network diagram and replace it with an adjacency matrix? And it becomes really easy to just remove one component and then come over here and say, okay, let's pull in some other component. So, maybe I'll pause there. There's certainly a lot more, I think, to say about this, but this is, I think, really what's necessary in order to move from analytics to applications. You need to be able to very easily connect together components. You need to be able to get into the code in order to make new components, either see how other components work or make new components. But you also have to have an abstraction layer around the code It lets different languages work together, like Python and R and JavaScript. Lets different technologies work together, like D3 and WebGL and Canvas rendering. And lets back-end technologies work together, like Hadoop and machine learning and these pieces. So, that's what we've created at Exaptive. And, the fundamental excitement and what we sort of named the company after is that what we believe is that by lowering the barrier to this sort of application development, this rapid application development, by making it easier for people to pull components from this whole repository of components that other people are contributing to, we think we can actually facilitate innovation, both inside an organization and a team and across organizations. And we've started to see that happen. We've worked with companies like the Gates Foundation and with Cohen Veterans Bioscience. And in these big analytic endeavors, one of the challenges is trying to give people visibility into the different things that are being done and to help them collaborate in ways that can actually lead to new ideas. And so, maybe for people that I started this by talking about networks, right? And we looked at a flight network. I'll sort of wrap up this part of the demo by talking about networks again, because what's interesting about the way we've designed this system is that this program, right? This is the data flow for this application. This data flow is itself a network. And so if you sort of think about the recursivity of that, what it means is that Exaptive can not only analyze network data, but it can also analyze the networks that are the applications being built with it. And the reason that's important is that that allows us to create a network based on how people use the application. So when somebody accesses a particular data set, we can show the other data sets and algorithms and visualizations that frequently get connected in that network. And then more importantly, we can show who's doing that connecting. And this, I think, is a critical piece, is that when it comes to data analytics, I think there's a lot of focus on trying to help people connect the dots. That's the cliche. But I think it's easy to forget that behind all of those data sets of dots are really smart researchers and analysts, and that what we have to do to facilitate innovation is not just help people connect the dots, but we have to have a platform that also connects the people that are connecting those dots.
Wow. That's awesome.
Tour de force. Can I ask some questions? And some of them are just
Sure.
simple. If I were developing anything in Python, I would use PyCharm on my Mac. If I want to connect that environment to this, is that easy to do? Yeah,
you mentioned on one of your slides service-oriented architectures, and at its heart, what Exaptive really is a rapid development environment for building service-oriented architectures and consuming service-oriented architectures. And so what that means is anything that can expose a HTTP or TCP interface, anything that can communicate through the web, can be componentized and integrated inside Exaptive. And that's why, when I started by building a component here, if I go into the studio, you'll notice that when I said that I wanted to build a component, there were a couple languages here. What I think is important is that those are languages that we have built-in support in the IDE for making it really easy for people to edit, so like this. But we're not limited to only those languages. So we've connected components to Java servlets, compiled code. We've connected components to .NET servlets. So, we've connected things to our servers and to clusters that are running their own, actually proprietary. We've done work with companies that have proprietary clustering things. So yeah, there's certainly going to be the case that there are technologies that Exaptive will not be able to connect to. There's certainly cases like that, but we've tried to design it with the main idea being to be as agnostic as possible and be able to connect to as many possible sources as it can.
Okay. Next question. If I want to go and play with this, is there something for guys like me that I can just log on and start playing with it?
Yeah. So I've done many startups in my life, and when we started Exaptive, we decided to bootstrap the company. And so when you do that, cash is king, and we started the company by being very careful with our free trials. And we got the company off the ground by working with organizations and doing proof of concepts, paid proof of concepts with them. And that was the way for them to get, access to the platform. And if the proof of concept went well, we would give them a discounted, we'd let them apply 50% of the proof of concept cost towards licenses. Now that we've grown, this is the most common request we get. That previous approach was a really good approach for getting our company going and managing our cash flow. Now that we've grown and we have a lot of broader visibility, we get a lot of requests for this. And so we are putting together a free trial environment. Basically, it's a cloud-based environment that will have a community edition that will be free to independent developers, to any developer really, for non-commercial purposes, but something that they can go in and they can kick the tires and they can build Zaps and they can see how it works. We are having that community edition roll out at the end of the year. We are working with people in an early access capacity, which is maybe something of interest for people that are listening, which is if you're interested in this, we take a very customer-focused view of development. So what we do before we roll out any sort of product or feature like this community edition is we work with some early access members. We give them early access, and in return, we ask them to just give us some feedback, and actually I have them give a 20-minute presentation to the development team about their experience. And we've been doing that over the last couple of months. No matter how much time you spend trying to build software inside your company, you're always going to learn things by working with people outside and getting their perspectives, so we take that pretty seriously. We're almost through that process. We'll be making this community edition available at the end of the year. But if there's anybody who's listening that would like to sort of get in before we do so, get some early access in return for 20 minutes of feedback, we're still doing that over the next couple months before we roll out a wider community edition.
Okay, the third question, you mentioned doing this HPE Haven hackathon. Do you have some relationship to Haven? Are all the various Haven components available through Exaptive in some way?
Oh, interesting question. So we don't have a relationship with Haven. That was just that we happened to be at the hackathon that they sponsored. We now have this is sort of the beauty of reusable development. Like, we now have a couple Haven components, and so we're going to publish them in the Zap store for community members to use. But we don't have a full suite of them, and that's something that, if that's of interest to a community member, then actually I'd be interested to find out if there's somebody who's listening that thinks it would be fun to try and sort of flesh out the rest of those components in the Haven library. And, we would certainly give them early access to do that.
Well, yeah, and, I was at a Hewlett-Packard conference recently, and I did have a play with Haven, and I had a play a few days later. And it does have some interesting functionality in it, and they're built, it fits into exactly what you're doing. So the idea of your environment and their environment being able to shake hands just makes great sense to me. And some of their components are really powerful, and some of their components are, more interesting than powerful. But that's because that's the next question really that kind of I'd like you to ask. And I don't think you can answer this question absolutely. I think it's kind of a relative thing. But as soon as you start doing this situation that you've done, which is clipping components together, you get into the problem of managing a library. And as soon as a library has many elements in it, if you can't easily find what you want in the library, you assume it's not there and build it yourself, even if it is there, but you find it. So what are you doing in that area?
Yeah, I'm glad you're bringing this up. This is sort of a nice, maybe a nice piece to wrap up on, because I know we're getting towards the end of the hour. This is something that this idea is sort of near and dear to my heart, because I've watched a lot of really promising platforms sort of crumble, not crumble is maybe too strong a word, but sort of diminish in utility under the sort of explosion of parts phenomenon. You end up with lots and lots of parts, and then it almost becomes too much. And we're seeing this even in non-analytics environments. You know, YouTube, you search for something on YouTube, and there's lots and lots of repeats of the same clip uploaded with slightly different editing or something like that. So this is something that at Exaptive, we thought about this from the very beginning. The hope is that we are going to continue to build this library by user-contributed content. We're very excited about that. And the concern is exactly what you've said. How do we make sure that that doesn't become sort of useless as it gets too many components? The answer, we do have an answer to that, and it's one we're excited about. The answer is recursivity. And what I mean by that is that the data about the components in the system is itself something that Exaptive can analyze. And all of the city pages, so we think of Exaptive as a sort of virtual city because we're interested in innovation and collaboration. So
Conference recording has stopped.
That's just the back.
So, okay. So we call this Exaptive.city. But all of these web pages that you're seeing here, everything you're seeing, including the IDE itself, which is over here, these are all zaps themselves. So we use the Exaptive platform to build the interface to the Exaptive platform. And the reason that that's exceptionally powerful is that as we start to get this explosion of parts phenomena, we will be able to use all of those parts to build applications to navigate the parts. And that is what we're hoping is going to be a really powerful sort of feedback control that as the system gets more and more components for data analytics, it will get harder to navigate, but it'll also get more powerful at being able to navigate complicated data terrain. And by making sure that the system was built inside itself in a sort of Lisp-like manner, we think that a set of zaps that can be developed are not just ones working on external data, but ones that work on the internal data of the zaps and components being developed by the community.
Well, that's a very good answer. I have to say, you got any questions, Eric?
Yeah, there's a really good question from one attendee asking about the role of enterprise architecture in this context. I realize what you're creating here is a sort of dynamic window into what we have traditionally called enterprise architecture, but if you're an enterprise architect out there, what might you do with this tool, or how might you use it?
Well, yeah, that's a great question. I was, you know, before I founded Exaptive, that was my role. I did enterprise architecture and I ran a team. And so one of the things that I think, so anyone who has an enterprise architecture role, I think, will appreciate how important this sort of system-level diagram is. System-level diagrams are sort of the currency of enterprise architecture. And so one of the things that we're excited about with Exaptive, and this is actually one of the reasons that the New Hampshire Department of Health and Human Services actually chose Exaptive as its platform for its next generation health dashboards, was because the act of creating a ZAP doesn't have to be about implementation. In fact, you know, if you remember, we went ahead and we created this component, the My Machine Learning component, at the very beginning of the talk. Well, now, but it doesn't really have an implementation inside it. This was just the default implementation. So what's nice about this is that we can create, you know, lots of components like this. So an enterprise architect can create placeholder components. So there's my new visualization component that's coming up. And then they can wire together. So let's come back in here. Now I should have my new visualization component. And they can wire up components like this that don't have implementations yet, but can then be delegated to the programming team to implement in a collaborative fashion. And so we see a lot of applicability in the data flow paradigm for making architecture not just a whiteboard drawing that gets drawn once and people never refer to it as frequently as they should, but actually making it a living skeleton for the code development.
Yeah, that's really good stuff. And something else you mentioned I think really should be called out again, which is you were talking about a dynamically generated network, and you reminded me of a concept I'm trying to flesh out that we're seeing more and more, where you're getting what I'm calling a sort of inside-out view of the world instead of the traditional outside-in view. And what I mean by that is the outside-in view would be a system architect's opinion of what needs to be put in place in order to meet a certain need, whereas the inside-out view is that you build something and then you monitor very closely how it's working, and you let the data that is spinning out of the system itself help redesign the architecture itself. So you're trying to focus on what's happening and building around the activity as opposed to building what you think is going to be required to handle the kind of activity that happens. Is that a fair assessment?
Yeah, I think what came to mind as I was hearing you mention that is I was just thinking about when I started my career, I was trained in waterfall development strategies, and those have all been replaced by agile development strategies. In a certain way, I think, you know, you're saying the same thing. The waterfall strategy was sort of figure out everything in the beginning and then hope nothing changes. And, you know, the agile methodology is much more sort of inside out. So it's not that you don't do some planning, but that you don't get too divorced from the implementation. And what makes agile work is it's not that hard to adjust sprint to sprint. What we're trying to do with Exaptive is sort of take the same principles of agile development that work so well organizationally, and we're trying to create a platform that actually allows that same sort of agility for developers and architects as they iterate on the actual implementation of their software.
Yeah, that's great stuff. Well, folks, we've burned through more than an hour here. I think this is really fantastic. Robin, I have never seen anything quite like this. Have you?
No, I think there are a number of things about it, some really neat little features. You know, one of them is the way, I mean, I think of these as sophisticated objects, if you like, because, you know, an object as an idea works at every level. But the way that this is represented, just looking at the screen as it is right now, to me, that was perhaps the most comforting thing I'd seen for a long time, because I realized that I could drive down into it, I would know what the inputs and outputs were, it had hidden the complexity of whatever it was doing. Under there could be a huge data warehouse run on some dramatically large piece of hardware, or it could be, you know, 20 lines of code doing something. It didn't matter. I could just work out what was going on. It's got the documentation, you know. And I think that's one of the things, is it kind of put everything on the same kind of level, and you can see what's going on. You know, and I think Dave's comment, you know, really about it being that an intermediate layer diagram. Oh, I'm sure that that's entirely correct, but the neat thing about it is it's a really good one.
Well, thanks, Robin. I think that, you know, it's interesting. You sort of used two vocabulary words that I'll just sort of illuminate for a second. Earlier, you talked about functions in your slides, and right now you talked about objects. And I think what's interesting is we've seen a war between object-oriented languages and functional programming languages. And there are, heated debates about when to use which or which one's better. The reality is that there are pros and cons to both. And, I think one way to think about this data flow that we're looking at here is that it is a marriage of object-oriented principles and stateless functional programming principles. So you have objects represented in the components, but you have functional programming in the way that data moves through those objects that looks much more like functors. And so, I think what we've really tried to do with Exaptive is allow for the synthesis of good ideas, synthesizing data from different places, synthesizing components from different languages, and also sort of synthesizing the best of object-oriented design and the power of functional programming.
Yeah, that's great stuff. We have one question here, the last question I'll throw at you. I'll just read it verbatim, and I think I understand what she's asking, but you can kind of decode this a bit. She says, so the system builds its own taxonomy of components and then makes recommendations based on taxonomy/search input combinations when users want to decide whether to reuse, edit, or create new. Can you kind of parse that?
Okay, yeah. So I think I understand the question, or at least I'll answer how I understand the question. So it's, she's talking about taxonomy of components, so how are components organized? And we have some basic taxonomy like algorithms and visualizations and data sets. But what she's getting at in her question is a more important taxonomy, which is a taxonomy that emerges out of usage patterns.
Right.
And that is something we are capturing in the community edition. And if you want to, there's privacy provisions in place if you don't want this information shared. But one of the things that we think is really powerful is not looking at the data that flows through the wires, right? We're not interested in that. That's sort of proprietary. That's inside the edges. But looking at the types of connections that are made between components creates a taxonomy of usage that can then help inform suggestions for other people. And this is very similar to how Amazon is able to suggest, people that bought this might also want to buy this, or Netflix is, if you like this movie, you might like this other movie. What we're doing with Exaptive is we're taking that sort of recommendation system to the active data science. If you like clustering, you might also like principal component analysis. If you are using a network diagram, you might be interested in a hive plot. Some people don't know what a hive plot is. It's a way to compare networks. And what we want to do is we want the Exaptive platform to not just be something that not only be a tool that helps you build things faster, but we're really interested in the end of the day in innovation and things we can do that make recommendations not about sort of sameness. A lot of the recommendation engines we see in the world today, like Amazon, are about suggesting other books that are like that. What we're interested in doing with the taxonomy that emerges out of Exaptive is to help lateral thinking, because we believe that that's where innovation happens. And we've actually worked to develop algorithms that will suggest things across domains and across disciplines, so that you have a chance that if you're working on genetic data, but you're doing a lot of clustering analysis, you might get suggestions of clustering algorithms that are being applied in the geopolitical space, where there's a lot of clustering on communities and political entities. So yes, that is a very key part of what we're doing. That is still early. Our first goal with Exaptive was to make the development environment as smooth as possible. And now that we have that, we are ramping up the suggestion piece, which we call the cognitive network. And so that is something that is continuing to evolve, and we're really looking forward to community members giving us feedback on it.
Well, this has been fantastic stuff. A big thanks to Dave King and his team over at Exaptive. I think this is just really wonderful and interesting, and I love the perspective and the philosophy and the vision that you guys have. I really do think you're at the epicenter of a new way of building applications and looking and understanding at data and applications and analysis and the whole kit and caboodle. So well done, guys. We will archive this webcast. You can always find more at insideanalysis.com. And with that, we're going to bid you farewell, folks. Thanks again. We'll talk to you next time. Take care. Bye-bye. All righty, that is